Okay, hello. Today I will be explaining percent error and percent yield. So we'll start off with percent error. But what is percent error? Percent error is the ratio of an error to an accepted value. Okay, so say you were to conduct an experiment and you got the densities, it had 3 trials, and you got the densities of 1.54, 1.60, and 1.57. And these are the units, grams over centimeters cubed. So, for this experiment, the accepted value for density is 1.5 grams over centimeters cubed. So, to go from 1.59 to 1.54 is negative 0.05. And then to go from 1.59 to 1.60 is plus 0.01. And from 1.59 to 1.57 is negative 0.02. So, the formula for percent error is equal to error over accepted value times 100. So, for trial 1, to find the percent error, you would put 0.05 error over the accepted value, 1.59, times 100. And don't forget your units. So then you would get 3.14%. For trial 2, percent error is very similar, obviously because you use the same formula. You take 0.01 over 1.59 times 100 is equal to 0.63%. And then for the last trial, for percent error, you take 0.02 over 1.59 times 100, and that equals 1.26%. So once you get these percents, what does that mean for your experiment? That means that 0.63 was closest to the accepted value, which means you had the smallest amount of error in that trial. And in the first trial, you had the largest amount of error since it was farther away from the accepted value. Okay, so that is percent error. I don't think I forgot anything. So yeah, it just basically shows what am I trying to say? How close each trial was to the accepted value. Okay, we will move on to percent yield. Percent yield is a little bit more complicated. It has a little bit more math in it. Okay, so percent yield is the ratio of the actual yield to the theoretical yield. And theoretical yield is the maximum amount of product that can be produced from a given amount of reactant. And actual yield is the amount of product actually produced when the chemical reaction is carried out in an experiment. So basically, theoretical yield is the textbook. That's like the ideal when nothing goes wrong and the conditions are good. But actual yield is what happens in the real world when you're doing a real life experiment. So you have to take the conditions into account. Okay, so percent yield, is equal to actual yield over theoretical yield times 100. Okay, say you were given the example, potassium chromate is added to a solution containing 0.500 grams of silver nitrate and solid silver chromate is formed. If 0.455 grams of silver chromate is obtained, calculate the percent yield. So basically, we know the mass of silver nitrate is 0.500 grams AgNO3, and the actual yield is 0.45 grams of Ag2CrO4. Okay, so first step, what you want to do is write the balanced equation. The AgNO3 plus K2CrO4 yields Ag2CrO4 plus KNO3. And then you have to balance it, and it just so happens that it would be 2, 1, 1, 2. Okay, then the next step you want to do is convert grams to moles. So you take the grams that you were given, 0.500 grams of the AgNO3 times 1 mole of AgNO3 over 169.9 grams AgNO3, which is the molar mass. And then units cross out. So you get 2.94 times 10 to the negative third moles AgNO3. And I skipped this when I was writing it down earlier. But basically the next step, if you follow this arrow, that's what that is, an arrow, you take the 2.94 times 10 to the negative third moles AgNO3 times 1 mole Ag2CrO4 over 2 moles AgNO3 is equal to 1.47 times 10 to the negative third moles Ag2CrO4. And the reason you know it's 1 mole over 2 mole is because in the balanced equation, Ag2CrO4 has a coefficient of 1 and AgNO3 has a coefficient of 2. So you plug those numbers in and basically you divide by 2. So then you get 1.47 times 10 to the negative third. And then you plug that in back here and you can multiply by moles Ag2CrO4, the molar mass. So once you multiply by the molar mass, you get 0.488 Ag2CrO4. And then you can use the formula I gave to you up here. Percent yield is equal to actual yield, 0.455 grams Ag2CrO4 over actual yield, 0.48, or over theoretical yield, over 0.488 grams Ag2CrO4 times 100. And then you get 93.2 Ag2CrO4, and that is your answer. Alright, thank you so much. I hope